Okay, assalamualaikum. Welcome again to my channel, guys. So today we're gonna continue our previous video. I'm so sorry because in the previous video when I record my live streaming, so I thought that it will be fine. So but there was a issue for my sound, so it looks like my microphone didn't work very well. So this is the reason why there was no sound in my previous video, but it's actually you can follow through all of kind of topics. So which is sucks. So but yeah, we need to find out we need to going through more. We need to going through all of continue our question. All right. So today we're gonna discuss about still electronic structure, but just to finish the previous topic, which is we remains kind of like five question, and after that we're gonna continue for new chapter. Okay, we're gonna start for new chapter discussing stoichiometry in chemical reaction. So it's so important for the next part. So stay tuned in our channel, and then let's get started to complete our problem, to finish our problem. All right. So like as usual, I want to give you a key concept. Okay, I want to give you a key concept, and then after that we're gonna answer one by one. Okay, so yeah, which element has the highest electronegativity? Okay, which element has the highest electronegativity? So the concept is, okay, top right, okay, except the noble cases, okay, electronegativity is all about the how strongly, okay, electronegativity, okay, it's talking about how strongly how strongly an atom pulls, okay, electrons in a bond. And then now in the periodic table, electronegativity, okay, as you move uh right across the period, so which mean left to right, okay, electronegativity increasing left to right, okay, as you move right across a period, okay, increasing. And then when you go up when you go up, so from bottom to the top, okay, from bottom to top, it will uh okay, it will going to, if you saying this part, so as you move right across a period and up, it will increase. So this one is increase, okay, if you are going through the is as you move from bottom to the top, it will be increasing. So I just want to recap a little bit over here. When you are moving, as you moving from left to right, it will be increasing, okay, it will be increasing. But when you start from top and then going to bottom, it will decrease, Okay, this is the like in general, like general concept of electronegativity. So that means the element with the highest electronegativity, okay, the highest one, it will be near to the top right, except the noble gases. Okay, so as you can see this arrow, okay, this arrow, okay, you will see we need to find out which one that the right one, which one the most right. Okay, and then we need to find out which one that the most top. Okay, so in conclusion we will get top right. Okay, near the top right. Okay, so based on this information we know the cesium, iodine, oxygen, and lithium. And then if you take a look at the periodic table information, so over here, okay, over here, as you can see, I'm going to make it bigger. I'm going to make it bigger. So, you know, there is no information in the ACS exam like the name of each one. I mean, the name of the in the periodic table, just the symbol. So we need to understand, or we need to know one by one, which mean what I mean here is we need to know what's the name of this symbol. For example, cesium, we need to know where is the cesium. Okay, cesium is way down in group 1. Okay, in way down in group 1. Okay, I just want to take a look at cesium. CS, cesium, remember, CS. Okay, CS, cesium. So this one that will be super low negativity. Okay, super low electronegativity. And then how about the iodine? The iodine, it takes place in the halogen. Okay, iodine is in the halogen group. Okay, iodine, 53, number 53. So okay, so the issue here is because it's like in the in his in yeah, hike up but not quite the highest one. Iodine is not the highest one. Okay, because it's still over here. How about the oxygen? Oxygen, this is one really close to the top the right. Okay, really close to the top right. Okay, as you can see, we need to going up and then going right. Okay, and then which one that close to fluorine. So oxygen is the most close, so it's highly electronegativity. Okay, the answer it should be C. Okay, so based on the information in the periodic table, we can get the answer. Okay, why not? Why not was that iodine? No, because it's still okay. It's still in the top, in the bottom. Okay, like I mentioned, it's still in the bottom, not close to the top right. Okay, not close to the top right. So based on that information, we need to know which one that close to fluorine. Okay, close to fluorine. Okay, hopefully you can get the answer of this question. All right, again, just for recap, top right corner rules. Okay, except the noble cases. Think of fluorine as the king. Okay, think of fluorine as the king, and then we need to find out which one that the most like the closer element to fluorine. Okay, all right, and then again, the second one is should be oxygen. Okay, the second one should be oxygen. Okay, the second highest one is should be oxygen. All right, and then number 26. Again, number 26. Still, we are still discussing about the periodic table. Okay, so the question is more electronegative than arsenic. Okay, which element is more electronegative than arsenic and less electronegative than sulfur? Okay, which one that element more electronegative, okay, than arsenic and less electronegative than sulfur? Okay, let's take a look at the periodic table again. Okay, let's take a look at the periodic table again. Okay, so all right, if you take a look at the picture of periodic table, arsenic is in a group 15. Is in a group 15. As you can see, arsenic in the group 5. Sorry. Arsenic, it should be in the group of 15. Okay? Arsenic, AS, 15. And then, again, arsenic, number of atom, like atomic number is 33. Okay, 30, just for let me change this one, 33. And then less electronegative than sulfur. Sulfur is in the 16. So sulfur is 16. I mean, the group of like the group is in a group what's that, 16. Okay, so we want element, okay, between arsenic here, in arsenic in the period 4, and then sulfur in the period 3. Okay, which one that more electronegative than arsenic? More electronegative than arsenic, which mean we need to go to the right. Okay, we need go to right. Okay, and then less electronegative than sulfur. Less electronegative than sulfur, which mean we have to go down. Okay, or go left. Okay, so let's break this down one by one. Okay, chlorine is more electronegative than sulfur because it's too high. Okay, sulfur is chlorine is too high because go right. Okay, go right, which mean increasing. Okay, go right, which mean increasing. As I mentioned before, if we going to right, it will increasing because it's right to, was that right to sulfur, which we want to get the less, so it should be not, is higher than sulfur. And then phosphorus, okay, phosphorus, okay, we need to get more phosphorus, we need to get more, okay, we need to get more. So phosphorus is over here, right? Phosphorus is over here, we need to get more. Okay, if we go up, we will get the electronegative will be increasing. Okay, will be increasing. That's true. And then sulfur, when if we want to get less, which mean we have to go left. Okay, so go left, this is a sulfur, so go left is include, I mean, including phosphorus. And then if we go up from arsenic, we will goes through phosphorus as well. So the answer is should be B. Okay, using the concept that we already provided over here. Okay, so yes, the answer is phosphorus. How about tin? Okay, tin is Sn. So we going down, so like decreasing. Okay, it's decreasing. And then like all going down, so we want to go up. Okay, we want to go up, not going down. If going down, which mean it's already incorrect because we need to have more electronegative than arsenic, and which is arsenic is over here, we need to going up, not going down. So and then as tin is going down, so which mean is incorrect, is already incorrect. All right, so and then how about the oxygen? Yeah, oxygen is go up. Okay, oxygen is go up. Okay, oxygen is over here, go up, which means is more electronegative than arsenic. However, is still more than sulfur. Okay, both so oxygen are more electronegative negative than sulfur as well as arsenic. So the answer should be B. Okay, all right, and then number 27. Okay, so please, when the question is, when we are asked about the question about the which one that more electronegative and then less electronegative, please take a look at we need to if we need to know the value between two elements. Check their vertical neighbor first. Okay, check the vertical neighbor first. All right. And then again, number 27. Which equation correspond to electron affinity of chlorine? Okay? So, electron affinity, what's the meaning of the electron affinity? Affinity is the energy, okay, the energy when an atom, okay, gains an electron. Okay, gain an electron. Okay, so when we are adding an electron to neutral atom, so what we want is neutral chlorine gains an electron, becomes Cl minus. Okay, so we want neutral chlorine gains an electron, becomes Cl minus. Okay, so again, over here, this is the key. Gain an electron. Electron affinity is kind of like opposite to uh ionization. Okay, ionization energy, because ionization is we want to know like the energy needed to remove one electron, but electron affinity is like the energy when an atom gain an electron. So should be gaining, not removing. Should be gaining, not removing. So let's take a look at let's evaluate the option one by one. Okay, no, the first option, Cl minus, this shows loss of electron. Okay, loss of electron. How about B? This is for chlorine molecules, not the atom. Okay, and then how about C? Okay, again, show loss electron. Show loss electron, which means this is ionization. Ionization, not affinity. And then this one is affinity, which means gain an electron. So like I mentioned, based on this concept, we understand that the neutral one gaining electron, and then it will be chlorine minus. This is the affinity. And then when we want to take a look, when we want if we want to take a look at the ionization, okay, this one is correct. Ionization, this one is correct. So the energy that needed to remove one electron, and then this one is gain one electron. Okay, so uh, in shortcut, adding an electron, okay, to a neutral atom in the gas phase. All right, so yeah, so the answer would be D. Okay, it will be D. All right. And then another question again. Which pair of element is listed in order of decreasing first ionization energy? Okay, so ionization energy is energy needed, like I mentioned, to remove the electron. It increases as you go up and to the right. Okay, so it will be increasing when you go up and to the right. So as electronegative. Okay, so IE i.e. ionization energy will be increasing if we go to the right. Okay, increasing. Why? Because when we go right, it will be the proton will be more. Okay, will be more. So to take out one electron needs much more energy. Okay, and then if we go down, okay, if we go down, it will be decrease. Because what? Because we adding subshells. So to take out one electron is easier rather than the top one. Okay, so let's evaluate the value again. So which pair of element is related in order of decreasing? In order of decreasing. So again, natrium and magnesium. Okay, and A and Mg. Let's take a look at from the periodic table. Let's take a look at from, okay, let me, yes, okay, sodium and then magnesium. Sodium and magnesium. Okay, to if so start from natrium, correct magnesium, which mean it will be increasing. This one is increasing. The question, regarding the question, we want to get which one that decreasing. So this one is incorrect. Again, this one is incorrect because of what? Because we need to get which one that decreasing, not not increasing. How about the Mg, magnesium and aluminum? Aluminum. Okay, aluminum. So aluminum is number 13, which mean is increase, which mean from Mg to Al. Mg is left of Al, but due to electron configuration, Mg has slightly higher Ia. This one actually correct. Okay, let me take a look at first. Number 27 is, okay, so because of let's take a look at from the periodic table first before move on to another part. Okay, let's take a look at. So based on the information that I mentioned, energy ionization energy will be increasing from left to right. Okay, okay, so the issue here, okay, Al, oops, sorry, Al, okay, Al is I mean Al is, I mean right, then Mg is to the left of Ai. Okay, Mg is left of Ai. However, because of electron configuration, if we take a look at this one, it will be much more clear. Okay, 1s2, 2s2, and then 2p6. So this is already 10. And then if you take a look at for the, like we already did it, this one, right? 1s2, 2s2, 2p6, and then 3s2. Okay, we need to take a look at this part again. Okay, 2p6 and then 3s2. So this one corresponding to Mg. Okay, so 12. However, how about the Al? Al, we need to get one more. 1s2, 2s2, 2p6, 3s2. Let's take a look at 3s2 and then 3s2 and then 3p1. 3p1. 3s2, 3p1. The number is, yes, 3p1. Okay, so Mg is actually slightly higher. This one is actually correct. So the answer is should be P. How about the AL rather than AL and SI? So SI, subshell, subshell. Okay, so AL and SI is higher. Okay, SI is higher. So first this one SI also higher than P also higher than SI. Okay, again these both are wrong order. Okay, so we gonna move to the next part. Okay, we're gonna move to the next part. So yeah, let's take a look at another question. When the species F minus, okay, F minus and A plus. So let me, why I'm confused. Okay. Okay, again, when the species F minus and A plus and Na are arranged in order increasing energy for removal electron, what is the correct order? So arrange these species by how much energy it takes to remove an electron from least to greatest. Okay, the key concept, ionization energy is more stable. If ionization energy more stable, is harder to remove. Okay, compare Na plus already missing one electron. Okay, Na plus is already missing one electron. One electron missing. Okay, and then so it should be very stable. It's already missing one electron because ionization energy, okay, ionization energy is energy needed to remove one electron. If already removed, if already missing, to take out another electron is more difficult. Okay, so it's very stable. And then neutral Ne. Okay, neutral Ne. Ne is noble gas, noble gas, which means is super stable. Super stable. Yeah, we can do, but it's super stable. And then how about the F minus? F minus is extra. We get extra electron, which mean is the lowest one. Because it's adding extra electron, we can take out easily. So it should be F minus and E and A plus. Okay, right? So remember this concept. Okay, and then let's move on to number 30. The first three ionization energy of element X are 590, 1145, 4912. What is the most likely formula for the stable ion of X? Okay, the first three ionization energy. Okay, so if we take a look at, okay, it increase gradually. Okay, increase gradually. Okay, from this to this is increased gradually. Sorry, from E1 to E2, IE1, IE2, IE3. This one is increased gradually. I mean, like just double. But for IA2 to IA3 is kind of like 4 times. It's like high jump, big jump. Okay, so that means it's in like it's easy. It's easy to remove. It's easy to remove 2 electron. Okay, after that, so this is one electron remove, right? One electron remove. So this is neutral. Okay, and then take out one electron, which is need this energy, and then take out for electron 2. Okay, electron 2, and then need this energy, and then electron 3, like high energy. So after 3 electron, I mean a third electron, it kind of like so hard to take out this electron. So What is the most likely formula for the stable? Which one that the most stable? It should be P, because after the second electron getting removed, this one, okay, just getting removed. So to take out another electron again, it will take takes much more energy, which means the X2 plus is the most stable of this compound. I mean, of ionization, based on the ionization energy information. So the answer is B. All right. So yeah. Okay. We done for our was that for the our question. Okay, for our question about, or for our topics about electronic structure. So now move on to another question, another topics about stoichiometry of chemical reaction. Okay, let's take a look at it. Right? So now we are moving to another part, which is about stoichiometry and chemical reaction. This one it's so important, and then it's more likely it's more likely shown up in the ACS exam. All right. So now we are moving on this question. So I just want to save from the for the previous data, just, and then let's let's start for the next question. All right. So number one. So now we are discussing about another topic, stoichiometry, and then in this topic it cover much more calculation. Okay, it will be cover much more calculation, and we need to practice much more. And then if we want to take a look at detail in your textbook, you can take a look at a sub chapter about discussing about stoichiometry of chemical reaction or composition substance and solution in your textbook. And then this chapter align the big idea of atom, like, or we already discussed in the first video and the second videos. And then yeah, based on that part, we hopefully we can do one by one. I mean, we can solve all of the problem. Okay, let's get started. All right. So number one, Avogadro's number equals the number of, okay, Avogadro. So Avogadro's number is 6.022 times 10 to 23. But what exactly counting? What exactly it telling? What exactly is tell something? So like I mentioned, Avogadro number is 6.022 times 10 power to 23, right? To 23. But exactly what is exactly counting? So Avogadro is counting unit, right? Just like dozen, like 12 or others. Okay, so one mole is 6.022 times 1023 of anything, okay, of anything. Okay, so might be atoms, might be molecules, might be marbles or anything. Okay, let's review of each choice. Atom in 1 mole of O2, Seems logic, right? But hold on. Why? O2 is molecule. This is molecule. Okay, molecule, not atom. Which mean 1 mole of O2 mean like O2 means 6.022 23 molecules. No, it should be atom. Okay, not atom. Okay, so like I mentioned, it might be anything. Okay, like molecules or marbles or atoms. And then another one, atoms. Okay, so what's the answer? Atoms in 1 mole of atoms. This is better. If we are counting atom, then yes, 1 mole of atom is this one. Okay, yeah, still good, the answer is still good. And then yeah, this one is still good, it's still correct choice. Okay, still good, but let's see. Marble is in 1 mole of marbles. Yes, that's true as well. Okay, and then yeah, it's also true. Mole is just a count. It's still, we are focusing on atom here. But let's take a look at for the option D. Okay, atoms in 1 mole of atoms and marbles in 1 mole of marbles. So this one, it sounds wordy but technically correct. Okay, why? This sounds wordy. Okay, like something weird, wordy, and but technically correct, because 1 mole of anything, like 1 mole of anything, it's like 6 point blah 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 of anything. So it might be marbles, it might be atoms, it might be molecules, or many things stuff. So this one is more comprehensive. Okay, right? So remember this concept. Okay, remember this concept. Okay, 1 mole is telling us about like 6 point blah 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 of anything. Okay, of anything. All right, and then let's go through another question. Okay, which sample contains the least number of atom? Okay, each sample contains so each sample contains 1 gram. Okay, because as you can see, this is 1 gram, 1 gram, 1 gram, 1 gram. The question is which one that has the smallest number of atom. Just imagine if we have carbon, we have oxygen, hydrogen, and then iron, and then which one with the smallest number of atom? Okay, the total of number of atoms, which one that the smallest? We use the molar mass concept. Okay, use the molar mass concept. Then moles, the moles times Avogadro's number. Avogadro's number, and then we ended up getting number of atoms. Okay, so let's do quick comparison for each. Let's do comparison of each. Okay, for this one is 1 gram times 12. Okay, molar mass of this one is 12. Okay, molar moles, this one is 12. So we need to take a look at this one. So oh sorry, so wait. So we know the question, the mole. Okay, how to get the mole is gram per mr, which is more like kind of like you can see from the atomic number. So 1 gram 12, so it we getting ended up 0.083. And then how about this is for C, right? And then for O2 we got the 1 gram. And then how about the O2, the oxygen is 32, sorry. So it should be 0.031. And then how about the C? C is 1 to 2, right? 1 divided by 2, so 0.5. And then How about the D, the iron? How about the D, the iron? 1, this is for iron, okay? 1 divided by 56, so it might be 0.018 mole. Okay, for each one is mole, okay? Mole. Okay, so what's the answer based on this information? Okay, so we need to have the biggest mole. Okay, we need to have a biggest mole. Okay, so which one that the biggest one? Uh, so which samples contain the least number of atom? The least. Oh, sorry, the least one. So the least one, which mean we need to have the least mall. Okay, the least mall. Sorry, not the biggest one. If we want to get like which one that the highest one, we need to take a look at which one that the biggest malls. So based on this information, we don't need to like use this equation. Why? Because it's kind of like if the mall is higher, number of atom also higher. Okay, as well as so if the mass is higher, number of atom also higher. Okay, so based on this information, hydrogen is the highest one. Okay, the highest number of atom. And then the least one, it should be this one because this one is just like the least mole. Okay, so the answer it should be D. Okay, it's very very easy to getting the answer of this one just based on this concept. So just remember, you just take a look at was that the moles, okay? Number of atom. As long as the mass over here is same, okay? The mass of sample is same. This is 1 gram, 1 gram, 1 gram, 1 gram, and then we know the Avogadro's number, but we don't need to get, I mean, like calculate one by one of that one. No, we don't need to do that. Okay, so just using this concept, I mean, just counting of moles, we ended up getting the answer. So the answer is which one that the least one? The least one is D. Okay, the least one is D. So the answer it should be D. All right. And then let's move on to another question. Yes, we done for 1 and 2. Okay, remember just for recap, remember the Avogadro's number, and then what's telling us about the Avogadro's number is telling us about like 1 moles equal like 6.00 6 point blah 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 10 to 23 of anything. Okay, and then remember again the question, the number of atom. We can calculate we can count the number of atom by using equation moles time Avogadro's number. Okay, Avogadro's number, mole times Avogadro's number. But remember, we can solve the problem without doing calculation for Avogadro number, as long as, again, as long as the gram still same and then other things. Okay, and then yeah, we can go through another question. Let's roll on another question. All right. So now, what is the molar mass? What is the molar mass? This one is very easy as long as we understand how to use the how to use the periodic table. We just like take a look at one by one, and then take a look at one by one, and then we will get the answer. Okay, so how much 1 mole of the entire compound weigh in grams? So we need to find out. This is the molar mass. Okay, molar mass. So how to do that? We need to break it down one by one of each compound, I mean each element. Okay, so for each atom, K or potassium, okay, is 3. the K is 3 over here, right? K3. So just you can take a look at the periodic table. You can see from the periodic table, and then we ended up getting 117.330 gram. And then Fe or iron 55.85 gram because it's just one iron. And then how about the C2O43 means there are three of this one, so it contains C6 and then O12. Okay, C6 O12. Okay, so from this we just know that 12 I mean the atomic number is 12 times 6, and then O2 like 12 times 16, so 72. This one is 192, and then we need to sum up all of them together. So add it all up. Okay, add it all up, and then we will get 437.15 gram per mole minus 1. So the answer should be D. Okay, it's very easy, right? It's very easy. So just multiply subscript over here with first, then multiply by atomic mass, and then add carefully. Okay, add carefully, because sometimes like we lose point because of that one. All right, and then again, we move on to another question. Just take a look at my message. All right, let's go to another question. What mass of carbon is present in this molecule of sucrose? Molar mass of sucrose, this one. So how to solve this problem is very easy. So how much carbon inside them in grams? Okay, so the question is what mass of carbon, so what's mass of the carbon present in blah 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 blah. Okay, so the key concept, okay, this is so important. So molecules, okay, molecules will be moles. Okay, and then moles of sucrose will be moles of carbon. So moles of carbon will be gram. Okay, grams of carbon. Okay, step 1, convert molecule sucrose to mole first. Okay, convert the molecules of sucrose to mole first. Okay, mole of sucrose, as you can see, is 1.4 times 1020, and then divided by the Avogadro's number 6. So this one, it should be moles. Okay, moles. So the total of atom is this one. Okay, the total of atom is this one, like we are doing before. So remember, like this one, a number of atom. Okay, number of atom is Avogadro times moles. Okay, so now we are going to determine moles. So number of atom divided by Avogadro's number, yeah, the 6.022 times 1023. So it's around like 2.33 10 minus 4 mole. Okay, mole. And then what? And then sucrose over here, it consists of 12. Okay, sucrose have 12 carbon per molecules. Okay, 12 carbon per molecule. So now we have this one. This is for the whole molecules, but it's just for carbon it's just 12. So we can determine this one uh and then times for 12. Okay, times 12. So we getting ended up for one atom. So sucrose. So convert mole of sucrose to mole of carbon. Sucrose has 12 carbon atoms per molecule. So just this one is sucrose. Okay, mole sucrose. So times 12. So it might be 2.80 10 minus 3 moles mole mole carbon. So it's just one. Okay, this one representing 1, and then we have 12. We have 12. Now we already got the mole. We already got the mole. And then how to get the mass is very easy. So mole gram per molar mass, or MR. So we already get the mole over here. So we just plug those number, 2.80 times 10 minus 3, and then we will get the gram, and then this one is 342 gram per mole. So we getting ended up like if we time this one to this one, we getting ended up, okay, times, okay, around what, around 3.3 times 10 to minus 2 gram. Okay, let's calculate using calculator again. Who knows that might be this one is wrong. Oh, wait, this is not this one. Okay, sorry, not MR. Let me take a look at first. So what's the function of MR? Let's take a look at this one. 2.33 divided by 12. Up. We get the mole of this one. $66. No. Wait. 2 point. Divided by 12. Okay, and then times. Oh, okay. So to get the answer is easy, right? Yeah. So atomic mass number is 12. Okay, so wait, where is the, okay, the number? Okay, so this is one. If we have 12, kind of like we have 2.80 10 minus 3 mol C, and then mol C. Okay, mol C times atomic number, which is 12. Okay, so 2.8 3 times 12 gram per mole. So we can slot mole unit, and we ended up getting 0.0336 gram. So the answer is C. Yeah, the answer is C. All right, that's good. So the answer is C. Just remember, break it down, so molecules being moles, and then being atom, and then being gram. Okay, remember, convert molecules to mole. Okay, convert molecules to mole, and then again, uh, convert moles of sucrose to moles of carbon, because sucrose has 12 carbon per molecule, so it will be times 12, and then convert mole of carbon to grams of carbon. So this is the tip how to solve this problem, but it's kind of like a little bit confused when you never seen kind of like this equation, because you know, we need to think logically, because we need to start from this one and then convert it to another one, convert it to another one again. Okay, so please be careful to solve this problem. Okay. Yeah, so like I mentioned, we need to determine the mole of sucrose, and then we using the ratio you can determine the number of molecules. So this one is just for 1 mole, and then we have 12 mole of carbon, and then we getting ended up for the mole of carbon, and then we are doing the average atomic mass. We can do like average using the average atomic mass of carbon from periodic table, provide the last needed information to convert it. Okay, so using this value, we are ended up getting the value of the equation. Okay, so oops, sorry. Yeah, all right, I'm so sorry, I hide for the equation. Okay, but it's fine. So we can move to another part. Okay, what mass of carbon is present in 0.5 sucrose, blah blah blah, and then this is the information. So again, this one is mass of carbon is present in 0.5 mole of sucrose. Now it's already shown here the mole of sucrose. Okay, the mole of sucrose itself is already provided over here. So how to solve this one? So you know the mole is gram per mr. So uh or maybe we can use kind of like the previous one. So yeah, maybe let's 0.5, and then gram, and then 342. So we are getting ended up what, 0.5, like gram is 171, but it's just 12 carbon. So how to determine that one? Or maybe we can use another part. Let me 14. It should be not. So like we can use the like the previous one, like the previous example over here. Okay, so we already have the mole over here, so just time 12. Okay, 12 times 0.5, so it's my should be 6, and then now 6 times 12 for carbon atomic number, like atomic number, so it ended up getting 72. It's very easy to solve this problem. Okay, the answer it should be B for this question. Yeah, 72. Yeah, that's correct. That's correct. So as long as you have information for mole, it's done. It's done. You don't need to calculate with like more complicated equation or something like that. So you don't need to use this molar mass. Again, sometimes the information provided, actually we don't need it. Okay, actually we don't need it. So just like the previous question, we just use the mole itself. Okay, so first of all, we already have this one, 0.5 moles, okay, of sucrose, and then after that we times to 12. Okay, so we getting ended up 6 mole of carbon, and then how many carbon is 12 in sucrose, so just times 12, so 72. So in molecular compound, always use the subscript to scale up, okay, to multiply by molar. Okay, good, we good now. So what is the mass percent of oxygen in K2CO3 molar mass, blah blah blah. So now what is the mass percent of oxygen? Okay, so how to solve this problem? We need to find out the was that the moles again. Okay, the moles again, but now expressed in percentage, expressed in percentage. So use the formula like mass of percentage is like mass of oxygen. Oxygen is 3, right? Here is 3 in 1 mole, and then divided by molar mass compound, molar mass compound. Okay, so because of we don't have any information of the moles, we just use this one, mass oxygen in 1 mole, molar mass 1 compound, okay, of compound. Okay, so how so because of this one is 3, so 16 times 3, so it should be 48, right? So K2CO3 contain 3 oxygen. So how many grams of oxygen here is 48. Okay, 48. And then how about the total molar mass? Total molar mass is this one, 138.2. So the answer is this is and then times 100%. So we're getting ended up 34.73%. It's very easy for this one. Okay. Just remember, I just want to recap for this question. If the question is about mass of carbon, not in the percentage, okay, mass in carbon, okay, we can use the equation like moles, and then use the what's that, so kind of like this one, atomic number, number of atom, okay, sorry, number of atomic is like moles times Avogadro. Okay, and then same thing like this one, if we already get the moles, just time like how many in atom, that element. Okay, and then we getting ended up like this one. Okay, like this one, just times of this one. Okay, just remember this equation is quite a bit confused, but if we do it more and more, it will be more understandable. Okay, and then remember for this equation, mass percentage will be mass part of whole, okay, and then divided by part, like part per whole or whole times 100. Okay, make sure to count how many each atom are presented. Okay, and then again, there is another question. A 4.08 gram sample compound of nitrogen and oxygen contain this one. What is the empirical formula? So now it's kind of like opposite, like reverse. Okay, not like the previous one. Now is reverse. not like the previous one. Now the question is about the compound, not the how much it is. So originally the sample compound of the oxygen is 3.02. This is the oxygen for the oxygen. And then there is also nitrogen. So NO. So the total of NO, we don't know whether NO2, NO3 or others, I don't know. So this one is 4.08 gram, but it contains 3.02 O2. Okay, oxygen. So you have sample made the made the of nitrogen and oxygen. So the total out of 4.02, 3.02 is oxygen. What is the simplest whole number ratio? So how to solve this problem? The key concept, the first one is using the simplest ratio. Using the simplest ratio. Okay? Ratio. So subtract to get mass of nitrogen. So subtract to get moles or to get the mass of nitrogen. The nitrogen how much? 4 point NO is the total of NO is 4.08. The if we subtract to get the mass of nitrogen, we will getting ended up 6 0 and this one. So this one is should be for nitrogen, and then this one oxygen is this one, I mean 3.02. This one is oxygen. Okay, now we can plug into the what's that, into the this one 6.0 1.06, and then this one is 3.02. So based on this formula, okay, so the oxygen, based on this formula, we need to convert grams to moles first. Okay, so this is the gram of nitrogen, this gram of oxygen. Okay, so how to do that? So moles of N. Okay, just like gram per mr, so 1.06, and then divided by mr, home like 14. Okay, so we will get like 0.07, right? 5. And then how about the oxygen? Moles of oxygen is 3.02 divided by 16, because oxygen. Okay, nitrogen is N2. Okay, this one is 0.18. And then now we will get the number. Okay, just using divide by the smaller number, the smallest number. Now we can get the smaller number is N, right? The smaller number is N, 0.05 rather than 0.188. Okay, so N is 0.075 divided by 0.075, we get 1. And then how about O? 0.188 divided by 0.075, we will ended up like getting maybe around 2.49. So it might be close to 2.5, not quite a whole number. So it might be, yeah, so it might be 2.5, right? We rounding this one 2.5. So now we know the nitrogen is 2 and then oxygen also 2. So it will be N2O5. Okay, because we just times 2 and 2, so this one N2, and then this one. Okay, so this is the concept how to solve it. Okay, right, so recap, if you get the decimal like 2.5, just times after that. Okay, all right, so again, if remember, the first step is we need to know the mass of each compound, each element, which is nitrogen and oxygen. We already know the oxygen already. Oxygen is already 3.02, and then the nitrogen is like, if we subtract between oxygen and then the whole sample, it might be getting ended up, it give us like 1.06, and then we are doing calculation to get the moles, and then after that we divide it with using the smaller one. So the smaller one is nitrogen, and then we get the ratio after that. So the ratio is 1 and then 2.5. So because of it contains, like, it's impossible, right, if we are using like n1, and then, so like I mentioned, if we have n1 0.25, it's kind of like not uncommon, right? This one is uncommon, so we need to just make it common, so it might be N2O5, something like that. So it's pretty easy. Okay, and then ibuprofen, a common pain reliever, contains, okay, remember, 75 carbon, and then 15 oxygen, and then 8.8 hydrogen. Okay, so what's the empirical formula? So same thing. So just assume the total is 100. Okay, the total is 100. The total is 100. So how to solve this problem is pretty easy if we know which one that has the smaller moles, So for example, for this one is divided by 12. Okay, divided by 12. This one is divided by 16. This one is divided by 1. So if we are using our calculator, we can ended up kind of like 75 divided by 12, so we getting 6.25. And then how about the oxygen is 15.5 divided by over 16, so we're getting 0.69. and then for this one is 8.8. which one that's smaller one is this one, so divided by this one, it should be 1. Okay, and then how about this one is, let's see, 6.25 divided by 0.9. Okay, so it's getting ended up 6.79 or whatever. And then this one, how about this one, 8.8 divided by 0.69, so it will be 9. Okay, it will be 9. So now we will get the answer. So it's probably okay. So we already got the C, 6.9. O is 1. Okay, and then this one is O is 9. Okay, sorry, hydrogen, it should be 9. Hydrogen, it should be 9. So now, based on this information, we can get the answer. Which one that the closer one? So if O1, it should be, it's close to this one. Okay, it's close to the A option. It's close to the A option. So but let's take a look at others. This is impossible because H should be 9. At least should be 9. How about this one? This one, O2, H also 18 is correct. And then how about the C? The C is kind of like makes sense, okay, if the C is 6.5, okay, 6.5. So just take a look at this one, take a look at this one again. And then again, how about this one? O is impossible because O is like less, it should be less than H. So which one that correct? To me, which one that correct? It might be the option C. Because of what? Because it might be close. Okay, the closer one is, the smallest one is this one. Okay, the close one is this one. So just the calculation of the equation. So 75.7. So I just want to take a look at more detail. I mean, the previous one I just using 75. If I'm like using 75.7 divided by 12, oh, this one it should be 6.30, and then divided by 0.96. So it should be, oh yeah, 6.57. So 65.7. So the answer it should be C. It's very easy. Okay, it's very easy. All right, so we done for uh our study question. Okay, study question. Now we are moving for practice question. Okay, we are moving on practice question. Hopefully I can finish for the whole part in one time. I don't want to postpone my work to be like much more. I mean, I don't want to postpone my work. So hopefully I can solve the problem soon. All of them. Okay. Okay, now I will give you key concept, and then hopefully I can also give the shortcut tip. Okay, shortcut tip. Okay, now let's do for this question. Okay, let's do for this question. All right, for question number 1. Which sample has the largest mass? Which sample has the largest mass? Okay, uh which of this one sample actually weigh the most on scale? Okay, the most on scale. 1 mole of marshmallow, 1 mole of Pb or lead atoms, 1 mole of CO2 molecules. All of these have the same mass. Okay, the concept is like I mentioned, like we are mentioning before, 1 mole. Okay, 1 mole, it should be 6.0 to 2 times 10 to 23 particles, or whatever over here. But different substance have different molar mass. The heavier molar mass is the heavier one mole will be. So how about the compared to molar mass? Okay, marshmallow, no, not a real chemical substance, but will weigh a lot less. Okay, how about the Pb? Okay, Pp is 207 gram per mole, and then CO2 is 44.01. So how to answer this one is very simple. So just pick the substance with the heaviest atom. That mole will be weighed the most. So the answer it should be B. Why? Because if you take a look at the pp, okay, the pp, the molar mass is 207.2, and then for CO2 is just 44.01. Okay, for molar mass. Okay, for molar mass is just this one. So pick the heaviest element. Okay. All right. Number 2. A 10-gram sample of which substance contain the greatest number of hydrogen atom? Which one that contain which one give you the most hydrogen atoms? Okay, the key concept, okay, you need to compare hydrogen atoms per gram. Okay, more hydrogen per molecule plus lighter molar mass, more each atom. Okay, so if we want to do this one by one, so for CH4 molar mass is 16, right? And then for HCl, the molar mass 36.5. This is 2. This is 34. Okay, the molar mass. And then how about the uh, hydrogen over here? Okay, more for hydrogen per gram, it has 4. Okay, it has 4. So just if you take a look at this one, gram 10 per gram is 16, kind of like this one. Okay, gram per mr. So let's comparing. So because the gram is same, okay, because the gram is same, you need we need to compare like which one that more hydrogen, and then which one that the lighter one. The lighter one is this one, right? The lighter one is this one. So if you comparing this one, 1036.5, 10.2, 10 over 2, 34.2, 34 point, sorry, 10 per 34. So which one that the most one? The greatest one. So based on this information, we can like get so quick the answer. This one is 0.625. This one is 10, yeah, 0.36, 10 divided by 36.5, no way, 27.3, and then this one is 0.10 to, oh no, not 0.5, this one is 2, and then 10 divided by 34 should be 0.29. Okay, based on this information, this one is the highest one, and then is 2, so it might be this one, the biggest one. So yeah, the answer it should be C. All right. Okay, lighter molar mass, more molecule per gram, and more each atom. Okay. Okay, and then the number 3, the number of atoms in 9-gram aluminum is the same as the number of atom in, we need to take a look at the molar mass of aluminum. Aluminum is 27 gram per mole. If you take a look at the periodic table, is 27. Okay, so based on this information, the number of atom, okay, the number of atoms, so number of atoms, so it will be Avogadro's number, and then times moles. So now we have mole, this one, so 9 per 29, 27 grams. So it will be 9 divided by what, divided by 27, it will be 0.33. So we just need to calculate this one. So which one, and then molar mass of magnesium is 24.3. So just times 24.3 times 0.33. So it will be 8.1. Okay, so the answer should be 8.1. Okay, it's very easy just using this question. So the shortcut tips, trick, like you can use the mass of aluminum, and then if I did molar mass aluminum, molar mass aluminum, and then mass mg, and then divided using set a proportion, just molar mass, what molar mass mg. So mass, this one is 27, and then molar mass is 0. This is mass, right? My mass is 9 over here, so molar mass is 27, and then this one is what's that? This one that we need to find out, and then this one is no, this is mass. Mass is, yeah, this is we need to find out, and then molar mass is 24.3. So we ended up the mass is 8.1. Good. Okay. Let's take a look at another one. Okay. So again, we wanna move to another question. We wanna move another question. Oop, oop, oop. Jig, 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 sound. It has sound, right? All right. So we're done for our yeah, our studi. I think the sound is good, right? Just want to take a look at in the video. Hopefully the audio good. Jake? Hopefully I can finish for the... Right. Yeah, I can see there is no issue. Okay, and then let's move on to another question again. So now a single molecule of a certain compound has mass blah blah blah, which value comes close to the mass of mole of this compound. Okay, so you are told how much one molecule weighs. Now we are asked how much do 6 blah 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 molecules weigh. Okay, the key concepts kind of like same. Okay, remember the molar mass is simply just multiply mass times Avogadro's number. Okay, so we just need to plug. So a single molecule of certain compound has this gram, which values come closest to mass of mole of this compound. Using this equation, this formula. Okay, use this formula. Okay, gram per mole. So now it's just we need to plug in this one. It's very easy. 3.4 times 0 minus 2, and then they will provide the Avogadro's number, 6.022 times 2023. Okay, and then we getting ended up like 204.7. So the answer, it should be D. Okay, it should be the closest one, So the question here, we are asked about like how much, okay, how much do 6.0222 10 to 30 molecules weigh. So how much that weight? Okay, how much that weight? Okay, you are taught how much one molecule weight. This is the key of the main point of this question. So as you can see, the molar mass is 200. So it contains kind of like this one. Okay, so if the mass of one molecule is 10.22, okay, if the mass of one molecule is 10.22, just multiply by 1023 and shift the decimal. Okay, so having this part, okay, 10 minus 2 and then multiply 1023, so it will give me us like a decimal place, so it will be give us like one place. So example, if like one, so if we have 24, so we need add one zero over here. So yeah, the answer is it would be the closest one is like 200. Probably it's much more. So quick tip, just one particle. Okay, if we have one particle, multiply by Avogadro to scale up of mole. Just remember this formula if you like don't understand. So molar mass, and then mass times Avogadro's number. Okay, Avogadro number. So yeah, let's build another I want to show you guys the book. Just like notes. Okay, the notes of the note of what is this one, Gen Chem 1 2. I will show you guys. Up, 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 up. Where is that one? I just want to show you the stoichiometry part, so we don't get any confused anymore. All right, what is that one? Chemical equation, stoichiometry, mass and mole. Okay, there is no summary of that one. Yeah, I have a chart that I will show you over here, so it will be very helpful for us to understand the concept of formula. Come on, guys. Yeah, I will show you. All right. So yes. See? So now we can understand more better. Okay? Relationship between mass, mole, and Avogadro's number. So I just want to writing down over here. So n and a or n per n a, and then n m per m, and then m. This one is n a, and then n per n a m. And another one is n m per m m. It's very easy. Okay, it's very easy. Okay, so now we have kind of like some sim more simpler, like simpler concept. Okay, and the big N is number of atoms, and then and small one is moles, and then Na is Avogadro, and then M small is mass, and then M caps lock is molar mass. All right, it's good to if you understand this one first. Okay, so a single molecule of certain compound, we already have this one, so molar mass. So the question is the molar mass. Which one is molar mass? Okay, the big one, M1. Okay, we have the information of mass, number of atom, probably. No way. Where's the mass? This is a mass, okay. And then this is Avogadro number. This is the molar mass. Okay, this is the molar mass. So we would say we can use this one. I would say we can use this one. So let's take a look at again. M mass of element, yes. And then N is number of, but this one is for number of atom. Okay, we would see probably this one. N is number of moles. We don't have any moles over here. Just mass time Avogadro number. Probably this one. Number of atom. This is Avogadro. This is the moles. Okay, this is the mole one. N per Na. No way. It should be this one. It should be this one. This one. M this mass. Oh, this one. N per Na times M. Yep, probably. Number of atom for this one, and then times M, molar mass. So from this one, we would end up getting M, and then M molar mass divided by Na. Oh, okay, Na, N per Na. Okay, so it will be M times Na molecular. This is mass. This is Avogadro's number divided by N. So because number of atom is kind of like single, we need to determine just this one. Yeah, that's true. That's true. Okay, let's go for another question. 25 of carbon dioxide okay, contains blah 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 oxygen atom. Okay, we know this one is 25 gram. Okay, and then molar mass is what? Is 44. Okay, 44. So how to get just divided by 44, we will getting ended up the moles. Okay, gram per mr. Mole. So we getting ended up 25 divided by 44. 25 divided by 44, 0.56. Okay, and then times what? Time Avogadro's number. This is small. 6.022 times 1023 times 6.022, 3.4. Yeah, the answer is should be B. It's easy, right? Yeah, it's easy. All right. But remember. How many? Oh, oxygen is 2. Sorry. I almost get trapped because oxygen is 2. It should be C. Okay? This is for 1 mole. Okay? This is for 1 mole. 3.40 times 20. Okay? But this one is for 1 mole. If we have 2, we have to put in 2, so 6.02. 6.84. Sorry, 6.84. Okay, sorry. Okay? So, yeah. We need to find out the mole first. And then we will getting ended up the molecule. So this one is mole of molecules. Okay, because we have 2 oxygen, we have to times 2. Okay, so using the shortcut trick, like multiply CO2 moles times 2 times Avogadro's number. Okay, just using this one, CO2 moles times 2 times Avogadro. Okay, because the oxygen here is 2, we have to times 2. And then again, how many atoms are in 1.5 gram of aluminum? Okay, how many atoms? So you know the aluminum is 27. Okay, so 1.4 gram, this is small again, divided by what? By 27. So the answer would be 1.5 divided by 27, it will be 0.055. So, and then with this one is small, remember, and then just times what? 6.022 times. Okay, so the answer is 3.3, blah blah blah. So C, the answer is C. It's very easy, right? No issue at all. Okay, this one times what? 6.022 times 10, 20, 30. So the answer is 3.35, 10, 22. All right, good. You get to go. And then, yeah, we need, I just want to double check for the answer. Yeah, actually, I have the answer of that one, but I want to do my calculation. Okay, right. Okay, good. We good. And then, again, we can move on to another part. A cup of coffee contains 95 of caffeine. Okay, 95 of milligram of caffeine. How many caffeine molecule are in 1 cup? So molar mass is this one. Okay, this, remember, this one is milligram. We need to divide it by we need to divide this one is 1000, because gram to milligram is 0.095 gram. Okay, so we have that mass. Okay, so we already have that mass, and then we need to know the moles. The moles is, mole is what? Gram per mr. So 0.095 per mR is what? Is non, okay, this one. So remember, this is gram per mole. So we'll get an ended up for the moles. Okay, and then divided by what? 194.2. So we will get 0.0000489, and then now it's time to multiply Avogadro's number. 6.022 times, okay, 23, okay, 2.9, okay, 2.9 E20. Okay, good. And then after that, this is moles, right? After that, the caffeine itself is what? 6.022 1023. Okay, we need to pause first. Right. So now we are going through another question again. Okay, so we're gonna solve another question. Assemble a compound of xenon and fluorine contains molecule of single type Xe xenon fluorine, where n is a whole number. If blah 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 of this XeFn molecule have mass blah blah blah, what is the value of n? So this question asking about kind of like the formula, okay, the formula of molecules what we need to do is like the previous one, we need to know the ratio. We need to know the ratio. Okay, so how to do that is simply we need to know the total mass and number of molecule. Okay, and then figure out how many fluorine atoms. Okay, so the key concept here is we already have the mass. Okay, we already have the mass, and then we already have the molecules. Okay, we already have the molecules over here. Okay, and then how to do that? The step one is find mass of one molecules. Okay, for one molecules. Okay, let's take a look at for this one. So molar mass is mass of xenon, and then plus n, right, times mass of fluorine. Okay, now we need to do what? Okay, the first thing, first in first, we need to know this one. Gram of the this one. Let me think first. XAF. Okay, and then 0.311 gram divided by 9.03 times 10 to 10. Okay, so now we know the mass of one molecule. Mass of one molecule is this one, 3.44 10 to minus 22. Okay, and then how about the molar mass? Molar mass is, we need to use this value times Avogadro. 3.44 10 minus 22, 6.022 10 23. So we getting ended up 207 gram per mole. Okay, 207 gram per mole. So remember again, we need to find out the mass of one molecule. Okay, so we getting ended up, okay, the mass divided by this molecule, and then we getting this one, and then we need to know the molar mass. Molar mass is moles, okay, times, okay, we need to know the concept of this one first. Okay, what's the concept? Is moles. Okay, it's moles. It moles is, no, not the mole. What's the concept of Avogadro's number here? Because it's correlated with the Avogadro's number. Okay, so what kind of the no, this one is not Avogadro number. Oh, this one is kind of like not MR. What this one? If 9 blah blah, this is the atomic, oh, the number of atom, probably the number of atom. So find mass of one molecule. Mass of one molecule. So gram. So mole gram per mR. This is the gram. This one, it should be mole. No. Gram. No, not like this way. Okay, mass of molecules. Mass of one molecule, and then molar mass. Oh, I got you. So we have this one, gram divided by the atomic number. So we have like so many molecules. Okay, so many molecules, and then we have mass. So mass divided by the number of molecules. we're getting ended up this one. Okay, this one, like a mass of one molecule. Okay, mass of one molecule is this. Okay, and then we need to know, based on this information, molar mass. Okay, molar mass, we can get molar mass based on Avogadro's number. Okay, this one times this one. Okay, oh, we getting ended up this one. Okay, so molar mass, like mol times Avogadro's number. Okay, this is Avogadro's number. And then what's the value of n? Now subtract xe. Okay, xe, which is xenon. Okay, 207. Okay, subtract 207, subtract with the 131.3. So how to get this one? Just take a look at the table periodic of xe. And then we getting added up 75.7. Okay, 75.7. Okay, 75.7. Now we have f is 19. Okay, f is 19, so we already getting like 3.98, which is rounding to 4. Okay, so the answer is should be 4. It takes so much time for this one, but it will be easy for us. Okay, it will be easy for us. Is there any like quick way to solve this problem? So the issue here is we need to find out this one first. Okay, find out this one first. 207. 207. Yeah, we need to find out the molar mass, this one first. Okay, 207. Okay. So because of this one, remember the total is 207, and then we have 131. This is still molar mass. Okay, and then we have the fluorine is 19, and then times n. So the total molar mass is this one. The total of molar mass is this one, and then this one is for xenon, this one is for Fe or fluorine, but we need to determine this part, how many this part, so it should be 4. So 4, if we have 4, so it should be 207, the total one. All right, that's good. But remember the formula of molar mass to determine molar mass of total. Okay, molar mass of total is just multiply mass per molecule, mass times Avogadro. Okay, mass per molecule. Now we need to find out this one using this one. Okay, I got you. Okay, so remember, we need to determine mass of one molecule first, and then using after that we getting one mass of mass per molecule, and then after that using the equation molar mass, which mean mass per molecule times Avogadro. Okay, and then after that it's done. We know the total of molar mass, and then just using the simple calculation, it's done. Okay, and then again number 9. Okay, we have this one. Sample is known to contain blah blah blah. What is the compound? Okay, the key concept still same. Okay, the key concept still same. So this one is known to contain 460. Let me bring this part. Okay, all right. So gram contain this one. What is the compound? Okay, what is the compound? Let me think first. So using the molar mass, molar mass is mass per molecule times Avogadro. Okay, so we know the sample is this one, 3.416 minus 6, and then this one 4 point, oh no, this is the number of molecules, this is the gram. We need to know first mass per molecule. Okay, so how to determine that is simply just 4.67 times 16 divided by 3.41 10 minus 6, and then Avogadro is 6.022 10 23. Hopefully this one is working. Hopefully 4.67, or might be we should be getting opposite. So yes, so yeah, it should be opposite. It should be opposite. So we need to know the per molecule, and then it contains this one. Oh, okay, mass. Okay, mass. It should be on top, and then 4.67, and then we getting around, this one is around what is 44 gram per mole. No, we need to match up between this one is molar mass, okay, 44. Okay, so we need to match up. This one is 16, this one is 12. Okay, this one is 44, this one is 18, this one is 17. So it should be this one, CO2. Okay, remember, we need to determine mass per molecule. Okay, if we are as about mass, so mass should be the top one. Okay, like the previous one, mass, it should be the top one. Okay, should be in the top one, not the below one. Okay, all right. Again, how many sodium ion are in 25 gram of Na2CO3, and blah 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 and blah blah blah. Okay, how many sodium ions are 25? Okay, now we need to just get the very easy, like moles. Okay, mole, so gram per ml, 25 gram per ml, 105.99. Okay, so the previous answer is P. That's easy for us. Okay, that's easy. Number 9 is P. Yep, that's right. And then move on to another question again. Okay, mole, and then divided by this one. Let me calculate again. And then it ended up getting 0.235. And let's take a look at for another one. Okay, so just times 6.022, 1.42, and then we ended up getting this one is gram per mole, so it should be mole, and then times what, Avogadro's number 6.022. So the answer is 1.42 1023 ions. All right, so the answer is C. Good. Up. How many sodium? Sodium, remember, sodium is 2. Remember, sodium is 2, so it should be this one, T. Okay, sorry, this one is for 1. If 2 to Na should be 1.42 times 2, so it should be 2.84. Good. A typical silicon chip, such as those in electronic calculator, has mass this one. Assuming the chip is pure silicon, how many silicon atoms are in the chip? So we need to determine the atomic number of silicon first, which is the silicon is what? The S is silicon. Silicon is 28. Okay, 28. Silicon is 28 point what? 28.09. So okay, this is the this is the molar mass. Okay, gram per mole. Oop, oop. Okay, and then okay, again we need to determine this one, right? Gram to be mole to be atom. Okay, molar mass again, and like I mentioned, molar mass is this one is gram per mole. So mass is this one, and then we need to determine the mole. So mole is 2.3 10 minus 4 gram per 28 0.9 gram per mole, and then we getting ended up this one is around 8.19 10 minus 6 mole. And then after that, how many silicon? So just using how many number of atom, right? Number of atoms, so 8 minus 19 10 minus 9 times 6.00022 times 10.23. So it will be what? 17. Okay, 17. No. Yes, 17. Yeah, so it will be this one. A. Will be this one. A. Okay, so yeah, it's like this way. Okay, and then number 12, a single tablet of regular strength Tylenol contains this one. How many moles acetaminophen in single tablet of Tylenol is very easy. It's very easy. 0.325 gram per micro per 1 point this one gram per mole. So what's answer? What's the answer? Zero point 0.00214 mole. So the answer should be A. Okay. Yeah, the answer should be A. And then again, we move on to another part. Just want to double check the answer. So good, you're good. How many moles in hydrogen atom are in 6 mole of CaOH2? How many moles of hydrogen atom are in 6 mole? So 6 mole in CaOH2. So hydrogen atom is 2. Okay, how many moles of hydrogen atom are in 6 mole of, okay, the total this one is 6 mole. Okay, the total is 6 mole. And then how about if we just have wants to know the mole of hydrogen atom? So in this case, we need to determine one by one. We need to take a look at first. Okay, each formula contain 2 hydrogen atom. Okay, so every one mole is 2 moles. Okay, every one mole it contains 2 hydrogen atom. Okay, it contains 2 hydrogen atom in 1 mole. And then how about like 6 mole? So it contains 12. Okay, it's contain 12 mole. It contains 12 mole hydrogen atom. So it should be 12. That's so simple. So number of mole time this one subscript. Okay, subscript. So just how many mole of hydrogen atom? So if if this one is 6 mole, so in the 6 mole of Ca, so like 12. Okay, what is the mass of 1.75 mole of Zn? Okay, what is the mass 1.75 mole of Zn? Zn. Let me take a look at the periodic table again. Zn is 65.39. So if we are asked about mass, it should be mass mole times molar mass. Okay, so mole is 1.75 and then times 65.39. So it will be probably T. Yeah, because zinc is, yeah. So it should be T 104 gram. Okay. 3TC is small molecule. Okay. And antiretroviral medication. What mass in gram of nitrogen in 7, okay, of 3TC. 3TC. Molar mass is this one. Okay, the question is asking about what mass. Okay, this is the mole one. So we're already getting the mole. It's very easy. This is the mass. This is moles. So it just kind of like cancel out. So we need to know the mass. So what's the mass is, like, just time it, like just multiply this one. 7.43 times 229.26. So yeah, 1.7. Okay, the answer, it should be C. It's very easy. Oops, but remember again. I'm so sorry. Remember again that the how many nitrogen over there, it should be 3. 2 times 3, so yeah, 5.11. 5.11. So what mass in gram of nitrogen? Nitrogen here is 3, right? Yes. Okay, should be D, probably number 15. Wait. I think I do miscalculation. 7.43 divided by 9.6. It's 0.0324 or 14. Not like this way. I think I thought that I think I make a mistake over here. What mass in gram of nitrogen is in 7 moles of 3TC? So 1 molecule of 3TC has 3 nitrogen atom, okay? And then so per mole 3TC we get 3 moles of nitrogen atom. So nitrogen atom is 14. Oh, yes. Okay, 14. So which mean 7.43 10 minus 4, it should be times 3. Okay, times 3. So we ended up getting 2.229 10 minus 3 mole. So we get n moles. Here is n mole. Okay, this is for 1 mole. Okay, this is for 1 mole. and then we get 3 moles, so it should be this one. And then now using nitrogen is kind of like 2.229 times was that 3, right? 14, yes. 0.01 times 3 times this one, 2.2, oh sorry, 10 point minus 3, so the answer is 3.12, 10 minus 2 gram. Okay, so the correct answer is should be B. So remember, and what mass in gram of nitrogen in moles of 3TC. So 3TC itself, so remember, just quick reminder, this one is for 1 mole. Okay, 1 moles. We want to have 3. So if we want to have 3, so this one should be times 3. Okay, should be times 3. Okay, because nitrogen here is 3, should be times 3. If we want to see A, we have to time A. Okay, times 3. And then now we have n mole, like as usual, moles. And then like gram per mr, this one is moles. So we want to see gram, so moles times mr is 14. Okay, that's good, that's good. So remember, here we need to determine for 3 first. Okay, for 3. Okay, sometimes we don't remember like how many atom over there. It should be 1 or 3. Okay, and then number 16, guaifenesin is common over the counter expectorant. What mass of oxygen is in 200 milligram dose of guaifenesin? Okay, now we need to determine how many oxygen here. Oxygen is 4. Okay, so we need to determine like at the end we want to times 4 for this one. So we need to determine for 1 moles first. 1 mole first, so 0.2 divided by yeah, 0.1 mole, 0.2 gram per 190. Yeah, this one. Okay, yeah, should be 0.00100, so on. And then we need to time plug here 0.00100, so on. So it should be 0. It should be 0.00400, right? So and then what's the question is mass. Okay, mass. Okay, oxygen itself, okay, oxygen itself is like 16. Okay, 16. So now we need to understand from here. Okay, like 16. So this is moles. Okay, moles of oxygen. So okay, 0.00, so times 4. Okay, times 4. And then oxygen itself, oxygen is 16. Okay, 004036, and then times 16, 0.16, so the answer is 0.0645. Yeah, the answer 16 should be C. Yeah, that's true, that's true. So now we understand how to get the answer of this one. Okay, just quick recap over here. We need to determine the 1 moles first. Okay, 1 mole, and then because oxygen is 4 over here, so we need to times 4. Okay, times 4 moles. Okay, and then after that just moles, this one times mass molar, mass, and then we're getting added up for the gram right here. All right, good. Now we move on to Number 17. A sample of ethanol contain this one. How many moles of carbon are in the sample? This is the molar mass. So hydro how many moles of carbon? Moles of carbon. A sample ethanol contains this one hydrogen. Then how many moles of carbon are in the sample? Hmm. Let me thinking first. How many moles of carbon? Okay, hydrogen here is, okay, let me thinking first. Hydrogen here is this one. So 3.024 divided by 1. So 3.024 moles. So if we have C2, this is for 6 or for 6, I think. Let me think. How about like if containing 6? Zero 0.5. So it might be 0.99. Hmm. Hmm. I think I'm a little bit tired, so I don't concern. I don't focus. So let me thinking again. Okay, let me thinking again. Okay. So ethanol has this one. So each molecule of ethanol contains 6 hydrogen. Okay, 6 hydrogen. So 1 mole ethanol is 1 mole ethanol, 6 mole of each atom. Okay, and each ethanol has 2 carbon. So how to do that? So now mole of hydrogen is 3.024 times divided by 1, 3 mole. Okay, 3 mole. Now its mole of ethanol, it's 6. Okay, it's 6. 6. Hmm. Yes, yes, yes. I understand. It should be the correct answer. Should be D. I understand 17. Yeah, D. But how to get it? Okay, like I mentioned before. So let me think again. So it's very easy actually. So this one 3.024 divided by uh, gram per ml. 6. Let me think. It's kind of like 0.5004. Okay, mole. However, it contains just 2, so just like almost 1 mole of C2. So it should be C. It should be just T. Yeah, that's good. That's good. No issue. No issue. No issue. Okay, no issue. It should be not exactly 6, but it should be 6 point maybe 0 what 6 times 1.001. Okay. Okay, so 3, so then 3.024 by 6.00 6.006. Yeah, yeah, 1 mole. Okay. What mass gram of oxygen does 25.5 aluminum carbonate contain? Smaller mass is blah blah blah. Okay, now move on to number 18. What mass gram of oxygen and then what mass of oxygen does 25? Okay, aluminum carbonate contain malware. Okay, so now it's very easy for this one. So aluminum carbonate is this one contain. Okay, so now just 25.5. This is small, right? Gram per 2033.99, and then 0.1089 mole. Okay, and then the question is oxygen. Oxygen on here over here is kind of like 9, right? 9. So times 9. It should be around what? 0.9808 moles. And then the question is gram of oxygen. So just mole times 16 times 16, 15.7. Okay, good. The answer is 15.7. And then the last question for this session, we will be gonna do for the last one. I mean the remaining question later on, not now. Okay. In the compound, this one, which element is present in the largest percent? Okay, the largest percent. Okay. So now, like I mentioned, we need to determine. Okay, we need to determine molar mass of each one. Okay, for hydrogen, is 8. For n is this is 8. For n, how much? N is 2. So 2 times 14, so 28. Oxygen is 316, so it might be 48. And then which element the largest percent by mass? Okay, for the sulfur is S2, sulfur is 32, so it might be 764. So the total of molar mass of this one is 148.222. Okay, which one that the largest one? So yeah, like we are saying over here that the largest one, it should be D. Okay, so there is a quick way to solve this problem, that the largest atomic mass times number of atoms. Okay, number of atoms. So over here, like we have 64, the biggest one. But if we want to take a look at the percentage of 64.14 divided by 148.22, and then we will ended up getting 43.3%. Okay, that's good. This is the biggest one. All right, so we're done for today. I will do it again later on for the rest question. Okay, see ya. Bye bye.